In this video, we'll write the balanced net ionic equation for AgNO3 plus K2S. This is silver nitrate, this is potassium sulfide. First thing we need to do is balance the molecular equation. I can see I have two potassium atoms here and just one here. So I'm going to put a 2 in front of the KNO3. Now I have two nitrates and only one nitrate here, so I'll put a 2 here. That balances the nitrates that also have two silver atoms, then just one sulfur, one sulfur. So that's the balanced molecular equation. Now we can write the states. If you know your solubility rules, nitrates are very soluble. We write AQ for aqueous. These will dissolve in water, split apart into their ions, dissociate. Compounds with group 1 metals like potassium or sodium, they're very soluble as well. Little AQ there. Silver, whenever you see silver, you need to be careful. Silver sulfide is insoluble. That means it won't dissolve in water. So when these react and it produces this silver sulfide, it's going to be a precipitate. It's going to fall to the bottom of the test tube. I'm going to write S because it's going to be a solid. Nitrates, again, very soluble. So we have our states. Now we can split the strong electrolytes into their ions for the complete ionic equation. So silver is always 1 plus, and the nitrate ion is always 1 minus. Good things to remember. 2 silver ions. And I won't write the states right now. Let's do that at the end. Plus 2 nitrate ions. Then potassium group 1 is positive. Sulfur, that's always 2 minus. This is 1 plus, 2 minus. We have 2 of the potassium ions, and then just 1 of the sulfide ions, S2 minus. Those are the reactants. For the products, because Ag2S, silver sulfide, is a solid, we don't split that apart in net ionic equations. So we just have that, and then we said plus and minus. So we have 2 potassium ions and then 2 nitrate ions. So once we've done that, we can cross out spectator ions. They're on both sides of our complete ionic equation. They haven't changed, so we're not interested in them. In the reactants, I have 2 nitrates. In the products, I have 2 nitrates. I'm just going to cross that out. I can see 2 potassium ions, 2 potassium ions. Cross it out. But everything else, it's unique. And that makes this the net ionic equation for AgNO3 plus K2S. I'll clean it up, put the states in, and we'll have our net ionic equation. And this is the net ionic equation for silver nitrate plus potassium sulfide. You'll note that charge is balanced. We have 2 times 1 plus, so the 2 plus and the 2 minus, they cancel out, give us a neutral compound here. And then mass is conserved as well. 2 silver atoms here, 2 silver atoms here. 1 sulfur, 1 sulfur. This is Dr. B with the balanced net ionic equation for silver nitrate and potassium sulfide. Thanks for watching.